There's a fish that hunts on land, not by leaving the water, not by crawling onto shore. It stays submerged, looking up through the surface, and shoots insects off branches with a jet of water precise enough to hit a target smaller than a grain of rice from 5 feet away. But here's the problem it has to solve before it can do any of that. Put a pencil in a glass of water and look at it from the side. The pencil appears to bend at the surface. It doesn't actually bend. The light carrying the image of the pencil bends when it crosses from water into air. The pencil is not where it appears to be. Now imagine you're a fish looking up at an insect on a branch. The insect appears to be in one position, it's actually in another. The angle of distortion changes depending on where you're positioned relative to the target. Every time you move, the distortion shifts. To hit the insect, you must aim not at where it appears to be, but at where it actually is. The mathematics that describes this phenomenon is called Snell's law. It defines the precise relationship between the angle of incoming light and the angle of refraction at the boundary between two mediums. The archerfish doesn't know Snell's law, but it behaves as if it does. Evolution has tuned its eyes, its brain, its body positioning, and its motor control to compensate for refraction automatically. Young archerfish are inaccurate. With experience, they build a sensory-motor map of distortion, refining their aim until the correction becomes instinctive. The archerfish never aims where it sees. It aims where the prey actually is. The archerfish belongs to the family Toxotidae, 7 recognized species, all sharing the same fundamental body plan and the same extraordinary hunting strategy. They inhabit mangrove estuaries, brackish coastal waters, and occasionally freshwater systems across Southeast Asia, South Asia, Indonesia, Papua New Guinea, and northern Australia. The mangrove ecosystem is their hunting ground. Dense vegetation overhanging the water. Insects, spiders, and small invertebrates clinging to leaves and branches above the surface. Prey that no underwater predator should be able to reach. The archerfish reaches them anyway. Early observers couldn't explain it. Local communities across Southeast Asia describe the fish as having supernatural aim, a creature that could reach beyond its world and strike targets in another. The name archerfish itself comes from this arrow-like shooting ability. The folklore wasn't wrong about the precision, it just didn't have the physics to explain it. The shot itself is a feat of biological engineering. The archerfish forms the jet by pressing its tongue against a groove in the roof of its mouth, creating a narrow channel. It then forces water through this channel by snapping its gill covers shut, generating pressure that propels the water outward in a focused stream. But the jet isn't uniform. The shot strength is adjustable. The archerfish can modify the velocity of the jet, the droplet pattern, and the force of the stream depending on the distance to the target and the size of the prey. The rear droplets move faster than the front droplets. As the jet travels through the air, the faster rear droplets catch up to the slower front droplets. The stream compresses. The mass concentrates at the tip. This is hydrodynamic focusing. The jet accelerates after it leaves the mouth. It starts at roughly 2 meters per second, and the head of the jet reaches approximately 4 meters per second by the time it hits the target. The impact force at the tip is significantly greater than what the fish's muscles alone could generate. The archerfish doesn't just spit water. It engineers a projectile that improves in flight. The physics of this mechanism resembles inkjet printer technology. The same principle of droplet coalescence that makes modern printing possible is being exploited by a fish in a mangrove swamp. The archerfish evolved inkjet physics millions of years before humans invented the inkjet printer. The shot can hit targets smaller than a grain of rice from distances of up to 1.5 meters, delivering approximately 200 millinewtons of force, enough to overcome the grip of insects that can hold many times their own body weight using adhesive pads and claws. What's less known is that the archerfish also jets water underwater, not just at aerial targets. It uses directed water jets beneath the surface to dislodge prey hiding in substrate, to flush out small invertebrates from crevices. The jet isn't just a hunting tool for the air. It's a general-purpose biological instrument. Before going further, 2 myths worth addressing. Some accounts claim archerfish can knock birds out of the air. There's no reliable evidence for this. Their jets are powerful relative to insects, but not large animals. The force that dislodges a fly from a leaf is not the force that brings down a bird. And the idea that archerfish shoot endlessly, firing at will without limitation, is also wrong. Repeated firing requires coordination and energy. Accuracy declines with fatigue. The archerfish is precise, but it's not inexhaustible. But accuracy alone isn't enough. The archerfish faces a second problem the moment the shot lands. The instant the insect hits the water, the race begins. Other archerfish are watching. They didn't fire the shot. They didn't do the work, but they're positioned, ready to intercept the falling prey before the shooter can reach it. Studies show that in competitive conditions, the archerfish that fires the shot loses its prey to competitors up to 44% of the time. This behavior is called kleptoparasitism, stealing food captured by another animal. So the archerfish has evolved a solution. It begins moving toward the predicted landing point before the prey hits the water, before the shot lands, before the outcome is confirmed. The archerfish predicts where the insect will fall based on trajectory, angle, gravity, and likely splash displacement. It calculates the landing zone in advance and starts swimming toward it while the insect is still in the air, within milliseconds of firing. And it does this while simultaneously accounting for competitor movement. Other archerfish are also predicting the landing zone. The shooter must predict not just where the prey will land, but where it needs to be to beat the competitors to that point. It's not just physics, it's game theory, executed in milliseconds by a fish. The archerfish can also shoot moving targets, insects walking across leaves. To hit a moving target, it must predict the insect's future position, calculate the travel time of the jet, and aim at where the insect will be when the jet arrives, not where it is when the shot is fired. And if the shot misses, or if the prey is close enough, the archerfish has a backup strategy. It can jump. Archerfish launching from the water to take prey directly is not a random leap. It's a calculated aerial strike. They've been recorded clearing up to 2.5 body lengths above the surface. For a fish averaging 20 to 25 centimeters, that's a vertical launch of roughly 50 to 60 centimeters out of the water. The jump requires the archerfish to breach the surface at speed, overcome gravity, and make contact with a target in a medium it doesn't breathe. It must account for the transition from water resistance to air, adjust its trajectory mid-launch, and strike with enough precision to actually catch the prey, rather than simply disturb it. The same refraction problem that complicates the shot also complicates the jump. The target's apparent position underwater is not its actual position in the air. The archerfish compensates for this too, launching toward the corrected position rather than the apparent one. It's not a fish jumping, it's a fish executing a targeted aerial interception from a standing start in a different medium. The boundary between aquatic and terrestrial isn't a barrier, it's a hunting zone. The eyes are central to everything. The archerfish has developed vision specifically adapted for surface hunting. Most fish vision is optimized for underwater environments. The archerfish spends much of its time watching the sky, scanning the vegetation above the waterline for prey, and those eyes reveal something unexpected. Experiments have shown that archerfish can distinguish between different human faces, even when researchers removed color cues and adjusted brightness to eliminate simple pattern matching. The fish still recognize target faces with high accuracy. Face recognition requires processing complex, multi-dimensional visual information, distinguishing subtle differences in feature arrangement. The archerfish does this with a neural architecture far simpler than the primate brain that scientists assumed was necessary for such tasks. The archerfish doesn't just see the world above the water, it reads it, which brings us to something that sounds like a joke, but isn't. The archerfish is considered harmless to humans. Its jet isn't powerful enough to cause injury. A direct hit feels like a light splash, but there are documented cases of archerfish in aquarium settings shooting at human eyes. Not randomly, deliberately. The eye's circular shape, high contrast, and reflective surface resembles the visual profile of prey. The archerfish identifies it, corrects for refraction, and fires. The jet won't damage a human eye, but the accuracy will. To the archerfish, a human eye and an insect on a branch are the same problem. A target above the water that needs to be shot. It isn't missing. It's hitting exactly what it's aiming at. The fish doesn't know you're not a bug, and frankly, it doesn't care. The archerfish's body coloration provides camouflage in the murky mangrove waters. Dark above, lighter below. A pattern that makes it harder to detect from both above and below the surface. It doesn't advertise its presence. Its primary defenses against predators are camouflage, early detection, and rapid downward escape. When threatened, the archerfish dives. It doesn't fight. It disappears because the surface is both its hunting ground and its most dangerous location. A bird can take it from above. A larger fish can take it from below. The archerfish is preyed upon by both simultaneously, and it isn't limited to aerial prey either. It also feeds on aquatic insects, crustaceans, small fish, and zooplankton. The aerial hunting strategy is its signature, but it's not the only tool. Young archerfish are not born with perfect aim. Juveniles have poor shooting accuracy. The precision that makes adult archerfish extraordinary develops over time through practice, experience, and neural calibration. There's evidence that archerfish can learn by observing other archerfish, accelerating skill acquisition through social observation. The same fish capable of extraordinary precision leaves its offspring to chance. Reproduction is broadcast spawning. Eggs released into open water. No pair bonding. No parental care. No protection. Larvae drift with currents until juveniles settle in mangrove environments and begin the long process of learning to shoot. The precision is learned. The survival is not guaranteed. In the aquarium trade, the archerfish has become a performance animal. Most fish sit still behind glass. The archerfish turns the tank into a shooting range. Hobbyists train them to shoot at food held above the water, turning the hunting behavior into a live demonstration. But they are not beginner-friendly. They require large tanks, brackish water, and open space above the waterline to shoot. They can grow to 30 centimeters. Most casual hobbyists underestimate these requirements. The result is stress, poor survival rates, and a fish that never gets to express the behavior that made it interesting in the first place. An archerfish in a small freshwater tank with no vertical space isn't an archerfish. It's a fish waiting to die in the wrong environment. The commercial trade is largely legal. There's no significant black market for archerfish. Despite its extraordinary abilities, it's not a prized food fish either. Occasionally consumed locally, sometimes sold in regional markets, but carrying no strong culinary identity. It's valued more for what it can do than what it provides. Despite decades of research, the archerfish still holds open questions. The precise neural mechanisms that control the shot remain unclear. The learning processes in juveniles are not fully mapped. The details of reproductive behavior in the wild are poorly documented, and the ecological impact of cross-environment hunting on insect populations above the water has barely been studied. Each answer reveals new questions. The archerfish has been studied for decades, and the complexity of what it does has kept researchers busy without exhausting the subject. What we do know is that the archerfish represents something genuinely unusual in the animal kingdom, a cross-environment predator that attacks organisms living in a different physical medium. The archerfish looked up at the world above the surface and decided it was hungry, and then it figured out how to eat it. If you want to dive deeper into the world's most bizarre creatures, hit subscribe. We're exploring the biological impossibilities that science is still trying to explain. And if you thought the archerfish was strange, wait until you see what we're covering next.